Okay, I guess we'll get started then. So I'm Tony Kelman. You've probably seen me on GitHub. I am going to be talking about making packages and distributing packages and dealing with binary dependencies, particularly C, C++, and Fortran libraries is most of what I'm going to be focusing on today. So I've got a repo that's just the notebook. We're going to be kind of back and forth and all over the place and doing a lot of things live here. So I encourage you to follow along if you, I think it's better to actually do these things kind of hands-on than just have me talk about it for an hour and a half. So I want this to be interactive. So this is GitHub tkelman/JuliaCon 2016 workshop. If you want to clone that, or especially if anyone is on Windows, you're probably going to be better off going through JuliaBox for now. I'm going to talk a lot about Windows specifically later on, but if you're not set up yet, JuliaBox is going to be a better idea to start with. So clone that repository, JuliaCon 2016 workshop under tkelman. And, okay. All right, yeah, so I need to figure out a way to make those the default. Yeah, all right. So I'm assuming a lot of people in the room, I guess how many people in the room have written a package before? Okay, good, a lot of you, all right. I guess those who haven't might be over hearing about how to plot things. So, which is also cool, also interesting. So if Julia has very good CFFI. A lot of us converts/escapees from MATLAB, Python, and R are very happy with how nice CCall is to use, especially interactively. Just called right into it, no glue code. It's great. But there's this big sort of dividing line between you can get things if you know a library that you want to call into and you look up the API documentation or the signatures in the header and you call into it with CCall. You want to get from being able to use this on your machine to then publishing your code or sharing your code internally with deployment, for example. So to get it easy to install, automatically, minimal effort on multiple different operating systems for users who are a lot less experienced with the library than you. So if you're writing the package, you're probably writing nice high-level Julian wrappers for some nasty, low-level, awful C or Fortran library that you don't want to deal with in that low level anymore. Okay? So you want to be able to do pkg.add or pkg.clone and just automatically, a lot of packages that are set up, this works reasonably well, to find, build, download the library across lots of distributions. Every different Linux distribution is a little different and has its own method and names for installing everything. And there's subtle differences that I'll get into between the library versions, and you get things running on your local Ubuntu system interactively, or your SSH into some server, but then you want to deploy it to some old CentOS VM that's ancient and nothing works, right? So I think a decent number of people are smiling and nodding that yes, they've had this happen before. So we work around this. We actually have a way to avoid some of this that we use when we make the base Julia generic Linux binaries that work across a lot of distributions. You just download and extract them and you're good to go. Not many packages are doing things that way yet, but I think I want to sort of show people that you can actually do this on generic package code too, and get things up and running that way if you want to. So also, on your local Macs for development. If you have Windows users, Windows 7, 8, 10. If a few people are still using 32-bit Julia occasionally, deploying on both. And then I won't cover in quite as much detail, but a lot of times if anyone is a fan of FreeBSD, or we're gonna have some talks I think on Thursday about using on ARM processors, right? That's a little harder to deal with, but a lot of times we can make sort of generic build from source fallbacks that will work a lot of the time if it looks and smells and walks like a Unix of some kind. And then a sort of nice to have would be if the person installing the package, doesn't have admin access to their machine. Can we even make it work in that case, under those constraints? Okay, so we're going to use as an example library a piece of R. So Julia, we're going to fix a milestone blocking 0.5 release issue live during this workshop, if we get far enough. So if you've checked this out, downloaded this, so we'll run the example, or so we'll clone the example. It's a piece of R that's the special functions library that isn't actually used by base Julia, but has been bundled in base Julia, and we're wanting to move it out to a package because distributions and a few other things use it. I think Doug Bates in the audience there wrote original wrappers to it long ago, and we're going to sort of modernize and use that just as a scaffold. It's an existing package that has some calls into the library. We're just going to use that as the name because it's the same library. Okay, so if you're on some a Linux or a Mac that has developer tools installed and you've cloned this repository locally, then you run make. Or if you're dealing with some more complicated library, you call it with configure and then make. You do cmake and whatever. So I'm assuming if you've written bindings to a library and then you're wanting to deploy them, which is most of the subject of this talk, that whatever your library may be, it might be some weird nasty thing, but I'm assuming you're used to it and have been able to build it at least once before and know the right invocation to do that. That's messy and different with every library, and I don't know if we're going to be able to make that a tractable problem other than by rewriting them eventually all in Julia, but that's going to take some time. Right, so you get a big mess of everything. The compiler, GCC, built all these C files, right? And then at the end, it linked it into a shared library. So that's the main thing that ccall needs the library to be a shared library. And most libraries these days, either you do configure -- enable shared. Let me make a console. So if you have some auto tools library, you do configure -- enable shared if that's not on by default to make it build an SO on Linux, a .dylib on Mac, or a DLL on Windows. Not all Windows libraries are going to use configure, but we'll get into that mess later. Okay, so if you have a shared library that has everything you need into it, and you've been able to build that locally, right? Okay, so we built this package. Now, as I said, this library used to came with Julia and will until this becomes a pull request and we take it out shortly. So if it's already something that is findable, that Julia knows how to find it, it's sitting next to libjulia in this case, or it's in a standard library location, you just give it its name, right? So your familiar ccall. You do the function name, the library name, the return type, a tuple of the input types, and then the input values, right? Familiar to anyone who's used ccall before. And in this case, great, we get p gamma of, I don't know what all the parameters are, but p gamma of 1 probably. Okay, and just to make sure, so that was the one that came with Julia, it was already able to find, and just because it might already be loaded, just to convince ourselves, let's just copy the one we just built, which is over in that rmath julia /src. We just built it as librmath-julia, and this is going to be SO on Linux, and it'll vary with your platform. And so let's copy it to librmath-julia2 just to convince ourselves and call that specific one, that specific location, right? Great, okay, we built it from source, it gave us the same answer. All right, so now the fun, meaty, complicated other part that is actually relatively uniform between different Julia builds. Everything we've done so far is going to depend on your own particular library, right? Your make invocation, what flags you need to use. But the rest, I hope, as long as it depends on your library how complicated it is, but at least for maybe half of them, most of what you need is probably that single shared library. So now what are we going to do with it, right? So we need to upload the binary somewhere if we just built it, and if we want to provide binaries that the user is going to download. So we just built them, we need to upload them somewhere. So what I recommend, if you don't happen to have a website or a storage space or something sitting around, is GitHub actually allows you to attach files to releases nowadays, which is pretty convenient. You can just do it through their web interface. So we have this rmath-julia. I can make a new release. We can just call it master. This is live workshop. All right. Choose an existing. Okay. Workshop tag. Great. So you can even do it through the web interface. If you're familiar with command line git, you could also make a tag, git push tags. Great. So we're going to just push that. And I missed the box. And GitHub is being slow. There we go. Edit release. Sorry. OK. So the box was here. OK? All right. So you can just attach any old arbitrary file that you want. My local system is Windows, and I have it somewhere here, but here probably. Lib. There we go. Really? OK. Well, it's going to complain at you and make you make a zip file. Oh, no. No, it won't. I clicked the wrong. Sorry. So it's picky about which that was uploading to the comment. Sorry, as if you were uploading an image to the comment. There we go. So the releases is less picky. So you attach binaries, not attach image to the comment. So attach binaries, dropping them here or selecting them. So this is the manual. If you just want to go through it, click, 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 go through. It works. It's not that hard. And now you should be able to see, if you go to tkelman rmath-julia and you go to releases, you should actually be able to download that DLL that I just uploaded if you built it yourself. So that's the manual version, and conveniently, you're probably going to want to build this more than once. You're going to tune it. You might need to patch it, do something weird, and you're also going to want to do this on a bunch of platforms. So you don't want to have to go through, find them all, click them all, do it all manually. So I'm going to show Travis CI, which a lot of people are hopefully using on your packages. When we do pkg.generate, we make a template. There's a bunch of different CI services, but Travis, because of Pontus, I don't know if he's in the room. Actually, Travis is probably the only one that explicitly has support for Julia because we added it. But it's not that complicated. But it built it for your Julia package. You just say language Julia, and you can do both Linux and OS X. For Windows, there's a different one I spoke about at a Lightning talk last year, and I'll get in more depth about AppVer. We also make a template for that. You say what Julia versions you want, and I don't know why email is on by default, but anyway, turn off spam if you don't like getting notified. So that's the Julia version. So if you've been using Travis CI, just one click, you go right to your repository, and where it's a narrower screen, somewhere under settings, there, I think. There we go. OK. So under your profile, you can see I have way too many repositories, but you can see you can flip the switch and enable Travis CI if you have this .travis.yml file. And I recommend everyone does this. The idea, if you're not using it yet, is every time you commit to your repository and every time someone submits a pull request, a potential patch to you, suggesting some change, it will automatically fire up a virtual machine, download Julia, download your package, install it, run your tests. So this is actually a very good sort of proving ground as you work on this bin dep or binary dependencies stuff that we're talking about. You've done it on your local machine. Now this continuous integration server that's spun up for you is a very good testing environment for you. So Travis CI, if you're talking not just about the Julia, but if you're talking about the C library itself, you can also do make, right, just on the virtual machine. Right? So you do language C. You don't need to download Julia to build your C library, probably. And you can just do make. And there's a good integration between Travis CI and GitHub releases. So every time you make a tag, so you say they have this deploy section here in the .travis.yml file. So you do deploy provider GitHub releases. And then you have to provide it a token. Okay? So the way you do that is you go to your GitHub settings, and you go to personal access tokens. And I have a few of them already, but you create a new one. And yeah, you enter your GitHub password. So you I think you might actually only need deployment. You either need repo or deployment. I'll actually test that. So you can describe it, say, for Travis to push to GitHub releases. You make a token because you're essentially giving with this token the Travis service permission to push a release under your GitHub credentials, right? So you create this token, and it'll give you, I don't think I want to show this while it's being recorded, but it'll show it to you once. So you copy paste. It's going to be some big long alphanumeric string. You copy paste that and record that somewhere secure locally. And let me actually turn off, just as a test, to see if only enabling deployment is enough. It might be. Okay, so you copy paste that, and then you go to the Travis settings on the repository, on your Julia, or sorry, no, not on your Julia package, on the pack. So if you have you'll sort of have to push the repository. If the C library is not already hosted on GitHub, you might have to download the tarball, git init, git add, if you want to push it to GitHub to make a local copy of it. Like, I don't think R hosts their source code on GitHub, for example, so we had to make this local copy at some point. But yeah, so Travis has an option, Travis CI, where you can set an environment variable, and it's a secure environment variable that no one can see. You can set it, but it isn't visible in the logs. People who submit pull requests to you are not going to be able to retrieve the value of it as long as you keep this to off. Right? So you give it some environment variable name, and this is where you would paste the big long alphanumeric GitHub token string. Okay? So I've made that available as the environment variable OAuth_token. And then in the .travis.yml, where are we? So in the .travis.yml, here under the API key, you give it the value of that environment variable. So this sets up GitHub releases from Travis CI to be able to automatically push release tags. Okay, and then you tell it what file to upload. Right. So here, the librmath-julia shared object, and here, since we're doing both Linux and OS X, we'll have an SO and a dylib. You need to set an option on for it to understand the star and not clean up. There's some extra options here. So if you do that, then every time you make the tag, Travis should have actually automatically uploaded the .so, right? So Travis CI, when I made that workshop tag release, I clicked manually make a release tag. It would also have done it if you had done git tag, git push the tag from your local machine. So this is where, a few minutes ago, it got to it on Linux. The Mac queue is longer, so it hasn't done it yet. But so this is what Travis CI looks like if you haven't seen it before, but it basically just ran make is what we told it to do. And then at the end, it installs some deployment. There's some Ruby code that Travis has that you don't need to worry about. So here, it used the token that I granted it as an API key to log in under my credentials to deploy to this repository and the current tag. Okay? And that's how that's where this .so came from. And then yesterday, I had also done it, and that had finished on Mac as well. So it uploaded the dylib and the SO. Right? So this is a really convenient way to automatically give yourself a place to host binaries if you don't have one already. Okay. So where were we? All right. And it also will do Linux and OS X for you. Now, the issue with OS X is where you build the binaries from matters. There's, as I mentioned, lots of different distributions. Travis CI by default is using kind of an old Ubuntu right now, 12.04, I think. There's an option you can look up in Travis's documentation. I think you do dist trusty, and it will do, I think you do like dist trusty and it'll use 14.04. They might make 16.04 available sometime soon. So a lot of times if you have a lot of library dependencies that your library you're trying to build into depends on, this can get kind of complicated to set up that build environment. So the way we address this for Julia and sort of for the generic Linux binaries of Julia, and kind of the trick here is you want to build on the oldest Linux distribution that you can use, that you want to support, but you often will need the newest compiler version. For example, if you're using something that depends on C++ 11 or a particular recent version of G-Fortran to avoid bugs or something, if your library is picky about the compiler versions, then you often need to use a new compiler version. So you need to run on an old operating system, an old Linux distribution with a new compiler. And since building GCC from source yourself takes a long time, yeah?
Does that lead to complications with something like live standard C++?
Exactly, yes. So you'll notice if you download the generic Linux binary of Julia under, so where is it? On JuliaBox, it's under Julia-0.4.5, I think, yeah. So under /lib/Julia, we actually include a private copy from the build machine, right? So the idea is we set up our build environment to use the newest possible GCC version, but in an operating system environment in a very old CentOS 5 or 6 that's going to be 5 years old or something, old enough that everybody who's probably using Julia these days is going to be using it on a system that is as new or newer. So Linux tends to be, if you build something on an old system, you can move it to a newer system as long as all the things that it depends on are available. So the new lib standard C++ sort of has to be vendored. And oftentimes you can get that from Julia, and it should work out. Same with Fortran. Okay. So if you've used, I find it very convenient to use Docker if you're working on a Linux host and a Linux build environment. They also have clients for a Windows host or a Mac host that is sort of virtual machine based. I don't use those as often. I usually tend to just SSH into a Linux server when I want to use Docker. But it's essentially it will tell you, it'll run in a container. It's like a lightweight virtual machine where you tell it what to pull from. And here I'm saying I want to make this container run in CentOS 6. And then this particular Docker container that I have actually downloads and builds GCC for you, so you don't have to do it yourself. So there are various hosting services for built Docker containers that you can pull from, and this is tkelman/C6G6, so CentOS 6 GCC 6. And I'm going to update this over time. There's on Docker Hub or on Quay.io, and I'll probably write down some more specific instructions. We're going to work on sort of formalizing this and documenting it better and providing a sort of pre-packaged environment, easy set of scripts for people to be able to do this widely, because it seems to be kind of tricks that not many people are familiar with. So we're going to make this easier to use. Right now, you could download this Docker container and be up and running with GCC 6, and the binaries that you were to build inside this Docker container would be able to run elsewhere. So when you do where did it go? When you do the GitHub releases, particularly the .so from Linux, we built this on Travis, so it was Ubuntu 12.04, which is probably old enough, but if you were to then try to use this on CentOS 6, I don't think it would work. So this is one way to get started, but if you want to be very careful and maximally compatible, you should actually use something a little older with the Docker container approach. But at least the dylibs, for example, from the Mac Travis, these should work on pretty much any Mac version as far as I know. Okay? So this is a good way, leveraging a lot of automation because you're probably going to want to do this multiple times for multiple packages and make it as easy on yourself as possible and not have to do everything by hand. Okay, so if we have the binaries downloaded or built on either locally or on some VM and then uploaded somewhere that anyone can download them on the internet from GitHub releases, or you can put them anywhere you want. Now we need to deal with making the Julia package download and install them. So from a very sort of simplistic standpoint, you could just, so when you make a Julia package, and we have this rmath.jl, so there's a hook built into the package manager that if you have a file under your Julia package at deps/build.jl, so it's this hard-coded path, if this file exists, so under your Julia package /deps/build.jl, this is a Julia script that for a registered package, anytime you add it, it will automatically run. Okay, so if I take an example, let's do, what's one that has a build script? I'm just picking something off the top of my head. All right, so if you add a registered package that happens to have a deps/build.jl script, you'll see this info building the package. All right, and let it do its thing. This is CMake and make building the file. Compilers are noisy, build systems are noisy. There we go. Okay, so it installed this. So you've seen this before. If you've worked with a pure Julia package, you just download the Julia code and you're done, right? That's the easy case. But then if you have this deps/build.jl script file present in the Julia package repository, that runs as a build step. So when the package initially gets installed, and every time it gets upgraded in versions, every time someone releases a new tag and you do pkg.update and it updates the version, the build script will rerun. And this script is any Julia code that the author of the package has put there. So you should be careful. I mean, you should actually look at the packages you install before you install and trust them. We try to audit and curate what's in metadata a little bit to avoid people doing any malicious things in their build.jl script, but just be aware of that. And also, never run pkg.add as root. Don't do sudo Julia and do pkg.add. That's not a good idea, generally. But anyway, so it'll run this deps.jl script, and it'll execute some arbitrary Julia code. And now we have a particular package called bindeps.jl. I mean, you could do anything in this script that you want, right? You could, for example, just run, OK, download, right? You could just say, copy that link. Where am I? You could just say, download that link, and download that file, right? And that could be your deps/build.jl script at a minimum. This is sort of the dumbest possible thing that actually does something useful. That would just download that file. Now, realistically, you probably don't want to download the Linux one for Windows users or Mac users, right? You be package specific, and then if someone's using it on 32-bit versus 64-bit, you probably want to upload those under separate file names if you want to support that. So this is sort of the bare minimum. Bindeps has a lot of pre-built functionality. It's kind of messy, and we're doing a lot of thinking about making it easier to debug and making a replacement for it that will hopefully work better, more reliably. But for now, it's sort of what we have, and once you set it up, most of the time it works reasonably well. If it doesn't, open issues, and we'll figure them out. So if you do bindeps, right? So if you want to use bindeps, then the first thing you do is you make your package depend on it, right? So there's this require file at the base of your package, right? So the default just says, what Julia version do I depend on? If you make this automatically, if you do pkg.generate, which in 0.5 is now pkgdev.generate, same thing. So the default just says, what Julia version am I using? And I'm assuming this is treated as if you only give one, this is all in the documentation, but if you only give one version number, that's the lower bound. If you were to give 2 version numbers, the second one is an upper bound, and the upper bound is exclusive. So this would say this supports any version of Julia 0.4, right? So you could do anything from 0.0.0 to whatever we're at today, yesterday. If you leave off the 3rd digit, it's anything within that release series. This would say this supports any version that's 0.4, but does not support a release version of 0.5. So once 0.5.0 gets released, this package would no longer be installable because this require file says, I don't support it. So I encourage people to think more carefully about the dependency version requirements, especially if you're relying on a lot of other packages. This is where you should put them, right? If you have compat, if you depend on data frames, if you depend on various other packages, you list them in this file as your dependency mechanism, right? So if you're going to depend on bindeps in your build.jl script, then you need to put it in your require file. So once you do that, when your package gets installed, bindeps will be installed, and then when you run when this deps/build.jl script gets run, you're able to do using bindeps, right? So the bare minimum, if you start, bindeps is built in a bunch of macros, which is unfortunate. We probably will not repeat that. So at a bare minimum, there's a set of scaffolding. You do bindeps.setup at the beginning, and you do bindeps.install at the end. And these are they're macros that expand to a bunch of other setup and tear down code. So that's a bare minimum. This doesn't actually do anything yet. But then there's a bunch of predefined functions within bindeps, okay? So you start, usually, if your package is calling into a C library, you say, I have a library dependency, and you're declaring this. So bindeps is kind of a declarative, this is what I depend on, and this is how to build it, how to download it, where to get it, what to do with it on different operating systems. So you start with, give it a name, so that we're going to say this is librmath. A convenient feature, a lot of Linux distributions especially will build these packages under SO names, where you'll have librmath.so.0.1. Whatever the version is. So a lot of times it'll come in different names, depending on whether the dev package is installed or not. So you can list a lot of these aliases. If there are a bunch of different names that the library is going to be found under on the system, you put these in aliases. Okay? So here, an alias that this library is going to be built by would be librmath.-julia, and we're going to put a 2 on it just to differentiate with the one that's currently installed, just to make sure that we're using the new one. Okay? And then something that you should really do is don't download the latest master of your dependency. If it's not something that you control, but really even if it is, downloading the latest master, you might have it work today, but then tomorrow you or the owner of the developer of the library commits something and changes something, that might break your setup, right? It worked today, then something changed and it doesn't work anymore. So you should really depend on specific versions of things, either tags, or if they haven't actually made releases, then you can actually put a SHA, the full commit hash, in here, and GitHub will usually understand it. Okay? So let's say, okay, so I declared this library dependency, and now I'm going to tell bindeps how to get it. Okay? So I do provides, and this is for the source. So I say I'm providing the sources for this particular librmath, right? And this is a Julia variable. This library dependency is a bindeps type. It's going to be a library dependency object. So I've said the librmath sources are provided by this tarball, right? So GitHub, when you make a tag, you can have a link. It will automatically generate the tarball for you when you give it the v0.1.tar.gz file name. And then a lot of times it'll be unpacked under some different name, right? So this, if we were to download this from the command line, let's go from the console. Okay, so if I were to just use curl and download v0.1 here, right, then I got the conveniently named v0.1.tar.gz. So if I then extract that, right, it's going to extract into this different folder name because that's GitHub's convention. The default is a lot of packages that aren't using GitHub necessarily will upload their tarballs where the tar name will usually be the same as the extracted name. It's kind of a convention that a lot of people follow, and that's the default in bindeps. If you don't provide one, it assumes that that's what it is, that's going to match the file name. But here in this GitHub case, it does not. So I need to tell it, when you download and extract this tarball, it's going to get unpacked into a different file name. Okay? So then I'm going to say, now that I've told it where to find the source, and next we're going to tell it what to do with the source. Okay? So a prefix, this is kind of a common AutoTools heritage notation of, they call prefix essentially where you install things, right? So I'm going to say bindeps.depsdir for this library, and that's the folder that we're in. So that's going to be the package directory, or maybe not. It's going to be wherever the package is installed, rmath.jl/deps. That's what this depsdir is, right? So I'm going to say the prefix of where we want the library to be installed, sort of just a convention, is under /deps/usr, user. Right? The source, where bindeps will download the sources to, it'll download them to a downloads directory, and then extract them into a sources directory. Okay? So the source dir is where it gets extracted to. So we tell it that. Okay, and this is going to match this unpacked dir usually. Okay, and now once we've told it where to download and where it gets extracted to, we want to tell it how to build it, right? So we would have done this by hand. We told Travis, we did .travis.yml, we just did make for this particular case. If your particular library might use configure, it might use cmake, it has some, whatever the invocation is to build it, you record this here. So this is the simple build, particular preset. There's also in bindeps, there's also some pre-baked ones for AutoTools. I don't think there's a cmake one yet, but maybe we could add one. Right, so this is a simple build is really just a series of build steps. And the build steps are some built-in things like download the sources, create the prefix where it's going to go, cd there, and then you could also do your arbitrary command objects. Right, so in the backticks, right, where you would do in Julia, we had done, or actually in the workshop, in the IPython notebook, for example. Right, so up here, right, we had done run the backtick notation for shelling out to other commands, right? So that's what the build.jl under the simple build, you can chain together a list of these, right? So in this case, it's go to the source directory, run make, and then in this case, because there's not really much to do install-wise, if it was an AutoTools library, you would probably do make install, and you would do, configure -- prefix equals the prefix variable that you would set. So there's a lot of examples of these, of more complicated examples of libraries that are built and set up pretty well to automate this bindeps process within Julia Opt and within Julia Web. And all over the ecosystem, but these particular organizations try to automate as much of this as possible. So a lot of times with bindeps, you kind of have to look at an example where it's figure out exactly how to adapt it to your particular use cases. Okay. right? So if your makefile has an install step, you would use it, but this particular makefile doesn't. But this particular makefile, we only care about the one shared library, and then just to check, just to make sure, I'm going to move it to the prefix /lib under a different name, just to verify. Okay? So this was providing a simple build, which was a set of build steps, right? So build steps begin, each line, get sources was a step, create directory was a step, and then this was a nested step. The change directory has to be the first entry out of a group of build steps, right? So you do build steps, it has to do change directory as the first thing. So you can nest them, right? You do build steps begin. Yeah?
What's the reason for nesting actually? Is that so the change directory doesn't affect the block? Or?
Right, the change directory I believe is scoped, and if you were to do this in not bindeps macros, then it would be a do block. You would do cd do. I think I had that actually in, where did I have that? I think if you read the code that you included, if you ran it, you should always read the code. So this clone script, I did something similar where, right, cd, where do I want to go, and then do, and then within that block, I'm in that directory, and then when it ends, it goes back to where it came from, right? So it's always kind of nice to leave things the way you found them, clean up after yourself a little bit, especially with changing directories and keeping track of where you are. Right, so I think that's the primary reason for the change directory to be nested in blocks like that. Okay, so I've provided a list of build steps for the rmath library. And then you can also, almost everything in bindeps, like I could also say the sources, for example. I don't think this would be very common, but if the sources for some reason depended on what operating system you were on, you could provide different sources for different operating systems. I haven't seen that very often, but maybe the build system is totally different and you would be downloading two different tarballs potentially. So the build steps especially, right? So this, if you were to try to run this assumes you have make, right? It assumes you have kind of build essential or the command line tools installed. And if you're a Windows developer, there's a bunch of different ways to get conventional Linux style make and bash shells. So usually, especially on Windows, you don't necessarily assume these are installed. It's probably not going to work if you try it on most people's systems. So usually the simple build we say is Unix only. Right? Okay, so if we've provided that much, and we've done bindeps install. Okay, so I was missing something at the very end, you provided a dictionary of, and this is, if you provided this dictionary, so this is from the variable name of the library dependency, right? So I said I did this librmath was the library dependency. So it's from that variable name within the build.jl script to a potentially different variable name within a generated file, right? So it just potentially built the library and knows where it is, right? It just built it. It knows where to find it. It also does a lot of checking. There's a lot of features in bindeps for doing validation steps. And I especially recommend this if you're worried about different versions of the libraries that you need to check for. If the API is changing a lot in the underlying C library, and you need to make sure your C call signatures match the particular version of the library that you want to use, there's extra options. So they're validation hooks. So I think some good examples of that are in Julia opt, as I mentioned. So the cbc.jl package is one particular example that has a pretty good build.jl file. So you can give it a validation function that takes the name, right? So you're going to look for, so the function is designed to take the name of the library or the handle of the library in the DL open sense libdl.dl open to dynamically open the shared library as a handle, basically a pointer to it. So what this function does is says if the dynamic library symbol in this handle and this particular function name in the library, CLP underscore version major. This is a function that exists in this C library. And then you want to return true or false, right? So if dlsim didn't find it, it would give you a null, a C null. So you want to say false if it couldn't find the symbol for this function name in the library. Or it's a try catch here. If there was an error, you also want to return false. This validation failed. So you want to say the validation succeeds if it found this function, right? And here's another example where different versions of this library had different APIs. Old versions of the library didn't have this particular name. So when you declare this library dependency, you want to say a keyword argument for validate, and you pass it the function name. So this will actually check if it finds libraries already on the system. BinDeps by default will use them. If it finds something under this name or under this alias, it will use the existing libraries if they're there, if it's able to find them. And if you pass a validation function, it will check everything that it finds and everything that it builds to see whether it passes your custom hook of, does this library have what I need? Is it the right version? For example, a lot of C libraries should have some function to ask what their version was. If the C library you're using is actively developed and does not have a function to ask what version it is, you should open an issue or a pull request for them to add one, because it's kind of a necessary thing these days, unless the library is totally dead and never changing again. So for example, you may just not only want to find the function name for what version am I, you might also want to call it, right? You might want to ccall into the library to say, what is the version number, and is it the version, the particular version, lower bound or upper bound that you need, right? Okay, so there's a lot of extra advanced features in BinDeps that it's a good idea to look into. But for this simple case, because I'm about halfway through, okay, so I think let's take a little, like a few minute break, I guess, because we're about halfway through. Or is this too short to do that? I guess the morning one was 3 hours. Built it in, right? So if we've set up this deps/build.jl script using BinDeps or potentially whatever else, if you want to try as a first cut just the simple download version, then you're welcome to go ahead and do that if it's easier for you. BinDeps, as I mentioned, if you already have the library installed, there's also a bunch of other features where you can do package managers. So for example, if the package is available on Debian and Ubuntu under a particular apt-get install name, then you can provide that as well. There's a syntax to do that in BinDeps to provide another way of avoiding building from source. Unfortunately, calling the system package manager is going to need sudo root access. So if you do this, it'll ask you, it'll say, I'm running sudo apt-get install whatever you told it to, or whatever the package developer told you the apt-get name was. So we will have to use sudo to do that. So that's a little annoying sometimes. If you're testing your package on Travis CI, for example, where we had mentioned the .travis.yml file, a lot of times, since if you don't have, did I not? I think I might need to pull it. Really? Okay. Oh, that's iJulia being annoying and not showing hidden files, and .travis.yml starts with a dot. Sorry. So we'd shown the .travis.yml file earlier for building and testing the package. Right, so this was our simple default one. But if the package then tries to say, I'm going to try to run apt-get install whatever because the bindeps file says it's available under that name. And if it doesn't have sudo access, on Travis you can actually say sudo true to get root access. Sudo false will run a little faster in a Docker container specifically. But so you could also do on Travis, you could say dependencies. There's an extra way you could do install and then sudo apt-get install, whatever, on Travis CI to set up the package. And that can be useful to look, for example, at a lot of packages that do wrap C libraries. If they have Travis CI, if they have a badge, for example, that shows them passing, I think Cairo.jl, for example, is one, or we moved it recently. Cairo.jl, for example, is very big and nasty and complicated and interdependent. This is an example where you have a lot of the advanced features of bindeps are sort of on display in all their gory detail in some of these bigger examples that we've gotten up and running. But for example, here you can see provides apt-get and what is the name, right? So this is the apt-get name for libcairo that provides the Cairo equals library dependency bindeps object, right? So if you see a build passing icon on Travis, and I think that's timeout on Nightly, and you're having difficulty installing Cairo.jl, for example, report an issue, first of all. Okay. Well, that wasn't a very good example because apparently that might already be installed, actually, or it might be building from source. Let's see. So the default Travis, right, installs Julia, clones, installs the dependencies. So when it was building Cairo, it looks like it probably just found them on the system. I guess the Travis CI VM has a lot of things pre-installed. But if we were to go here and run Julia and do pkg.add Cairo, it might take a second. It's faster on 0.5 because it uses libgit 2 now. But okay, so what does building Cairo do here? It's probably trying to use apt-get, and it might, I'm guessing in advance of it. It might actually be trying to run sudo and failing and then falling back to a source build, but let's give it a minute to think. Okay. Oh, right, there it goes. Oh, okay. We have it installed on JuliaBox already. So these are bad examples, sorry. But, okay, so there's other advanced features of bindeps you can use to leverage package managers as well, if that's easier for you. But anyway, so we said, as we left off before the break, we have this dictionary of what the library name was in the library dependency function, and then this is the name that it's going to get installed to, okay? So once we have that set up, and we do, so when you do pkg.clone, currently it does not automatically run the build script. We might add a keyword argument or something for that in the future, but at the moment, that's how the package manager works, subject to a little bit of refactoring. But if something fails when you do pkg.add and you get a big error message that says failed to install, failed to build some package, it'll tell you you can try again with pkg.build because it's its own separate step of basically just running that build script. Right, and here, okay, good, it just worked. It just said info building rmath, and it ran that script that we just wrote. So one thing that the bindeps does is if you give it a name to install to, then it creates a deps.jl file, okay? So under the deps directory, and the idea is you do not want to check this in. This is an auto-generated file. This deps.jl, so it's always a good idea to make a .gitignore if you are using bindeps, and some good folders. So for example, it'll download by default, right? So under deps, the default behavior is to download the tarball that we told it where to find. It downloads it into deps/downloads. and then it extracts it into there. And then it installed it once it was built into, ls deps/usr/lib, right? So that's where it installed it to, because we told it to install there. So these are sort of some default things that it's a good idea to put in your .gitignore, because you don't usually want to check in the binaries. Maybe eventually we do if we find a way to get it working on all platforms, but we'll see. And then this deps.jl, which is auto-generated at the end, right? So what does that actually look like? So this deps.jl it's commented. It says, this is an auto-generated file, do not edit. You should also probably say, and do not check in. So there's just a little macro that bindeps has generated. This is actually kind of the old way that we don't actually use as much anymore. But it does say, so it says librmath, this was the variable name that we gave it in the build.jl. This corresponds to the to part of the dictionary. The value gets written into here. And then the path, right? So if bindeps found the library somewhere else on the system, if it found it already installed from apt-get, or if you told it where to install it from apt-get and then it found it, this will give you a different path. So this is the full path name to the library, and this gets assigned to the variable name librmath. So this deps.jl is the usual sort of mechanism for the load time code, right? So the package itself, so this is the src/rmath.jl, the Julia file that gets loaded when you do using rmath, or this package, right? Module rmath. And I think if it would say your package code goes here in the default template that's empty. So there's this. This is sort of a common thing, a common little piece of boilerplate of how the proper way at the moment to load this deps.jl file. So there are some cases where bindeps might go wrong and might have not created the deps.jl file. So if you were to just say include deps/deps.jl, right? You could do this, and it's valid, but if it failed, if bindeps failed, and it did not create a deps.jl file, you would get include, I couldn't find it, which your users might find confusing, right? That's not the best error message for this. So it's a good idea to give kind of a more detailed, more specific error message. Another thing is, so if you want to check where it is file, I think, is the right way to check if a file exists. And I think that needs an absolute path. So a lot of people, their first instinct is, okay, what's the absolute path of where this package gets installed? And this is something that I nitpick and send a bunch of pull requests to fix in lots of people's packages. But at least those of you in the room or those of you watching this later can hopefully fix this on your own. And we should write this down in the documentation as a best practice. But so the right way to refer to your own package is not using pkg.dir, because you could potentially clone the package somewhere else for local development and add that to Julia's load path and run it from there. And then it would not be within the package directory. So this is something that, for example, if you're going to bundle packages with Julia, they will probably not be in the package directory on the user system necessarily. They might be somewhere else. So the right way to do that is there's the __ file macro. This expands to the absolute path of the currently running .jl file. And then dir name, right? What is the directory where it is? Okay? So that's the right way to get an absolute path of a file within the package. Okay? So you check if it's there, and if it is, you can include it. And if it's not, you give a nicer, more descriptive error message that says, oh, deps.jl was not created, therefore something probably went wrong with bindeps.jl. So try pkg.build again as the specific way to re-invoke that, and the user can hopefully report whatever goes wrong. Okay, so if you've included this deps.jl file that we showed here, the only thing that it really included was it defined this librmath variable, and it defined it as a constant, which is something that ccall needs. So if you give ccall a library name, I'm going to look through Doug's old code here to see. I thought I changed that. So did I? Yeah, okay. So I had done a pull. I fixed this probably over lunch. Okay, so the old code, the existing code had just libarmath as a constant symbol, just assuming that's always what the library is named. But maybe it's not. You know, it might be under some alias. It might be under something weird. So bindeps in the deps.build in the deps/build.jl file has done a bunch of work to find what potential names it might be and which one passed the validation checks, which one got installed, what is its absolute path, and saved it to this variable. Right? So if you're using bindeps and you've done the dictionary, the second part of the dictionary saves it to this variable name. So every time in your C calls, you refer to the variable name, you refer to the library name using that variable. Okay? All right. So, and that worked. So that built the library from source. Okay? So that did manually, or that told bindeps when installing the package how to run make. And you know, if the package then gets installed on a system with the developer tools, right? And we had shown, I think, on Travis. Oh wow, I thought I ran that a while ago, and the queue is unfortunately long. But so that will show. Okay, well, I can't verify that it works on a Mac. Did anyone test it on a Mac locally to see if the pkg.build of the myrmath.jl fork now works on a Mac? But anyway, so it did. Let's look at release. So it did make and built it at install time, and then used it and ran the tests. Okay, now there's also providers for binaries. Right? So we started off by saying, let's upload the binaries somewhere, and either ambitiously, or for example, if you do it on a Mac or a Windows machine. So this is Cygwin, which is sort of the best way at the moment if you're on a Windows machine, I personally cross-compile a lot of things from Cygwin. So the right way to do, because Cygwin will give you all the build tools, it'll give you make, you can run configure scripts in here, it has CMake and everything. And it has a set of cross-compilers. Yeah?
The bash from Ubuntu for the Windows is getting very interesting.
Yeah, so that's right here.
The Ubuntu version, or the Linux version of Julia.
Yeah. It doesn't pass all its tests, but it builds, and it's getting better, and it doesn't seem to understand Zoom, but anyway. Yeah, so that's why Firefox is having some weird glitching problems, because I'm running the unstable version of Windows to try this out. Yeah, it's pretty cool, and if you're dealing specifically with people who are able to use Windows 10, and have that version and are able to run the update that comes out, I think probably within a couple months, where you can actually go in and turn this on. You know, you have to go find the right setting and probably have admin access on your machine. It's in some weird Windows features thing that you have to look up the right instructions to enable. It's not on by default, but it's an interesting option. And because Cygwin maybe is a little slow or weird or not to everyone's liking, and it also, you have to recompile things. It still uses Windows binaries. Here, you could actually download a .so. It seems to be dead. Anyway, bash on Ubuntu on Windows. Yeah, so you can actually download an ubuntu.so, or even the apt-get install. Like, it's kind of weird to be using apt-get install on a Windows machine, but I don't know. libcairo too, right? It's really weird to see this happen on a Windows machine, but it's an interesting thing for people who are able to use Windows 10. Just not every environment, but yeah. So it's an interesting possibility, and it's something I didn't expect to see, but it's pretty cool. Okay, so where were we? So yeah, so we had built these binaries earlier, right? And On Windows, if you're building in Cygwin, you are actually doing cross-compilation, which is not as hard as it sounds. Basically, I'm saying, so it's a little different with every library. If it's a simple auto tools library, if you're doing configure, then actually all you really need to do, and the really cool part is this works on Linux too. If you install a cross compiler, so actually let's try it. So sudo apt-get install. This is kind of ridiculous that I'm installing a cross compiler for Windows inside Ubuntu on Windows, but that's what I'm doing. So Cygwin has it, and a lot of Linux distributions have cross compilers where you can build. It's using GCC, and it's cross compiling from either Cygwin or Linux to Windows. So you can make DLLs and everything. And I can, don't have probably enough time to go into all the gross minutia of making this work all the time. But in a simple case, if you're doing configure, then you do -- host, and it's this funny name that says I want a 64-bit Windows binary, and then this stuff is just some weird, confusing naming. But MinGW is the name of the cross-compiler project. And the compiler itself is just GCC with this prefix, right? So you invoke it the same way as you would GCC, but it builds, right? So in this library, I also need to say, in order to know, like, we have this particular makefile where we're saying, right, if OS is Linux, then I want an SO, and if OS is Darwin, which means Mac, I'm building a dylib, and if OS is Windows, I'm building a DLL. So if it's just a makefile project, hopefully it has some little logic like that in it. So I want to say OS equals WinNT, and then I want to say the compiler equals this prefixed MinGW32-GCC, right? So this from Cygwin, and it's exactly the same in Ubuntu, whether real or weird inside Windows Ubuntu, but it's the same. So I do OS name, or OS equals WinNT, and CC equals x86-64, W64, MinGW32-GCC. And of course that didn't work. That's what I get. I could SSH into a Linux server where I have this installed and actually working, but I don't think I have enough time to be worth it. But so this builds, you can build a DLL. So you invoke the compiler the same way, and if it's simple C stuff, this is something that we're also probably going to provide more containers and documentation. And there's actually a package. I mentioned this in my Lightning talk last year. I don't know how many people were there for that. But we have a package called winrpm.jl that is designed to actually download cross-compiled binaries that someone else has already built. And there's quite a few of them. So there's a whole list here. So if you're dealing with a library that, is common, some common open source library that you think probably a lot of people have had a need to build before and is probably a dependency of something, it might already be built. So I think we use this for example, Cairo. Right, and you can do a search for these. This is on the OpenSUSE build service, which is a particular Linux distribution that probably more people should use but don't. But anyway, they have a good selection of these libraries pre-built. And I've worked with a few people on, like if you're really interested in making this all work really well and think, like if you have a lot of dependencies, like we saw Cairo, we saw that bindeps script for Cairo, and it was like 8 different libraries, and they all depended on each other in funny ways, and it was a big mess. And you run the configure script, right? So you run the configure script, and it has all these nasty arguments, and if you don't have the right dependencies installed, then configure complains at you. It's all a big mess, and this is the part that is sort of different with every library that you're dealing with. But we've set this up from scratch for a few libraries, and I can walk people through that. Okay, so the way we do that, so like we had that apt-get provider, there are also providers for binaries, and let's just look at some examples. Oops. So as I mentioned, in Julia Opt, there's a bunch of good examples. SCS is one, and Ecos is another. These are optimization solvers. If you use Jump, this is what does the work underneath, depending on what kind of problem you're solving. Right, so this is, again, like we had just gone through with this RMath example, right? Provides the sources, and you can also say provides the binaries, okay? So, and this, the binaries are going to be OS specific. So this is where you would use that OS keyword argument. So you put the binaries up. There's also there's a website called Bintray, which is another option, sort of as a nice kind of open source, free for open source projects. You can sign in with GitHub authentication. And this is another kind of place you can just make or just upload generic binary builds of your various open source software in case GitHub releases is too much trouble. This is another option you could use for that. Sort of like SourceForge, but not as much spam as SourceForge has these days. Right. So you can say, right, the URL. Where did you upload that binary? Again, the unpacked directory. This particular binary has a bin 32 and a bin 64 for 32 and 64-bit windows within the same file. Another convenient validation thing, in case the binary is big and maybe downloading it gets interrupted a lot and corrupted, and if tar complains, not in gzip format, what is going on? A good idea is you can set a checksum, right? This is something that Homebrew and most other package managers do, is when they download a file, they also have the checksum recorded and written down to know what it should be. So there's a nice pure Julia SHA checksum algorithm package that does that verification. It's a good idea to add. Right, okay, so that was an example of this file that I built. I probably went and did, I might still have it around, I think SCS, no, okay, on my old machine. But so I did the same basic thing by hand and just uploaded them somewhere, which is a decent idea if you have access to either cross-compilers. And there's VMs, and we're going to provide images and stuff, images and instructions to make this easier for people to get their hands on and do. Okay, so I have a little more than 10 minutes left. I guess let's open up the rest for questions if people have, hopefully, some. Yeah?
A few questions. Okay, so in Travis CI, can you limit the rate that it does rebuild? Because I do a lot of commits, so I don't want it to rebuild every time. Maybe. So is there what kind of policy can you do?
Well, okay, so there's a few things you could do with Travis. One option is keep more of your work locally. If you're doing a lot of rapid fire commits, you could only push every few of them if you don't need someone else to look at them immediately. I also kind of like having lots of small commits if they're independent, building the work up and having the history a little more granular is nice sometimes. But then if you push everyone, it can get messy. We have some tricks in the base Julia repository because our queue is really long. So on AppVer, which is even slower and has even more of a queue time, we had to deal with this as well. They have a built-in feature where you can turn it on. They call it rolling builds. I should actually probably cover AppVer in the last few minutes. So they have a feature called rolling builds, where if you have made a new commit to the same pull request or the same branch, and there's a new queued build, then it'll skip the older ones. It'll cancel everything in the queue except for the newest thing and just run the newest one. So Travis CI does not have this feature built in, but you can actually write a script that's, 25 lines or so of bash that calls into their API with curl and recreates the same thing. So this is in the Julia repository under contrib called travisfastfail.sh, and you can invoke that in your .yml file. It's kind of, our YML file for base is really long and messy, but it's in here somewhere. I think early on here, right? So one of the first things it does is runs this fast fail script, and if it fails, it exits quickly. So it only takes maybe a few seconds instead of a few minutes if it's a big library. Oops.
The dev.jl, build.jl, what's the current directory when it runs?
It runs under deps. So it'll run in deps here by default. Okay, yeah, so I think I should mention the AppVeyor service. So if you can also get this set up for Windows, either by cross-compiling if you don't have access to Windows, or using this WinRPM, leveraging the OpenSUSE service if you found your binary already there, or if you worked through it. So AppVeyor is a service that's essentially Travis CI for Windows. And we also do in pkg.generate. Oops. No. So we also will actually make a template appveyor.yml file. And it's a little longer, but it's the same basic content of saying which Julia versions do I want. Similar kind of features of what branches do you want to build. This is a really verbose way of saying download Julia, install Julia, and then run PK, the same steps that Travis would do of clone the package, build the package, test the package, right? So this is a very good thing of also making sure, since Travis CI can cover Windows and OS X, you can set AppVeyor up to verify. And this is probably a good idea to do even if your package has nothing to do with binary dependencies at all, just in case you hit weird platform dependencies in your normal code, but especially with binary dependencies since they're so platform dependent. I definitely recommend with open source code. And they also have private options if you have private repositories, paid plans. So I think it's a good way of finding out about bugs immediately after you commit them, as opposed to after you release them and someone finds them and a user gets mad because something broke. It's always good to find out about bugs early. Any other questions? Yeah?
What's your recommendation regarding whether to pre-compile and provide them online or let the users?
So I think on Windows especially, if you want to support Windows, it's much, much, much better experience for your users if you provide binaries. On Linux, it's a lot less common to find, or it's a lot easier to get a hold of compilers and development tools. And same on OS X, right? These days, you don't need all of Xcode. You don't need a 5 gigabyte download to get Clang. These days, you do Xcode select install, and it's not that big, and it's probably the first thing most developers do on their laptops. One thing where if you want to support running a package that has binary dependencies on Macs that don't have the developer tools installed, then you also need to provide binaries. Oh, and I did not mention at all, we have, for what a lot of packages use for Macs, we have a package called homebrew.jl, and this is another, it's also structured as a binary provider. So if I go, for example, this is what some people may have noticed this, but if I go to Cairo.jl again as a big, nasty, complicated example. So this was on Windows, we use WinRPM to provide the packages that OpenSUSE has built for us, so you don't have to go deal with how to compile them yourselves. And then on OS X, you can use this homebrew.jl package, right? Because Homebrew has packages for many of these things, and it's what a lot of people like using on their personal Macs. So we have, through this using Homebrew, it's a Julia package called homebrew.jl, and you'll see in the require file, this is a feature that's probably most useful for these binary things, but you can actually annotate in your require file that certain dependencies are only needed on certain operating systems. Right? So Homebrew is only needed on OS X, and WinRPM is only needed on Windows. Right? And then you can wrap this. Changed syntax on master recently, but there's a version in compat.jl for it. So you can use Homebrew, and it installs a private Julia managed installation of Homebrew. sort of to keep things a little more isolated from your system-wide version. And this actually recently got rewritten, so the master could use a little bit of testing if people are adventurous. But this is another thing where you can write kind of a formula, and there's a contributor, Elliot Saba, at StaticFloat on GitHub, who we're very happy to have in the community. Not as active as he had been before, but hi, Elliot, if you're watching. So he has a set of sort of homebrew taps, and he has done a lot of work in packaging Julia itself and a lot of these package dependencies. So if you've ever written a homebrew formula, this is what these look like. So it's all a little different on every different operating system. It's kind of a fair amount of work to put all this packaging together. So I think, that didn't really answer your question directly. I recommend as much effort as you're willing to put in to make the experience smoother for your users. It's kind of a function of how many users you have and how vocal they are about, this was hard to install, help.
So you mentioned the official binary rules for Linux and VMs and things of that nature. Is there a description or scripts file that build actually?
We need to write one. So that's like something for me to do. Yes, we're going to try to make that as easy for people to use as possible. And there's a lot of sort of interesting activity going on in that environment. Like, I don't know if many people are Python users or familiar with Conda. There's sort of a very active effort that's actually in the open source ecosystem called Conda Forge, where they're sort of addressing a lot of the same problems that we are with automation and build environment testing and making it easy for people to build new packages. So we kind of are going to need to sort of help people standardize this and make it easier and documented and automated. And so this is definitely on our list of things to improve as things go forward. Okay. All right, I think that's actually our time. So thanks, everybody. I'm always around for questions online, offline. I'm around for the whole week. So.